Questions, comments? Can we take a break? So it's currently 10 something? 10:05. So let's say 10:15. All right. See you at 10:15, and then we'll play with tablet. Oh. One more thing, and then we'll play with tablet. Go take a break. Yeah.
Bridge.
Together.
Will.
Yes. I'm trying to get
That's what I was figuring out.
I think somewhere like 4 years ago, it's behind us. They don't really know that much to see it.
It was easy.
Faith so this was the one that got my attention. So we direction and so exam results for samples.
Oh, you're right. Like it's
Researcher wants to know train students score.
oh yeah, that's
Right, so that would be the direction. So,
oh yeah.
The researcher says if the scores are different from the national average, then that's the higher. So this and one of the videos so far, right? So at least one and the civil school. Not less because I feel like they're progressing. I literally felt like Hanson had wanted breakthrough. That's how I'm feeling. Okay, yeah, I would feel close.
Now.
Yeah, thanks for that. Good to know someone else. Like I said, like, you what? Just say that. Yeah. So, yeah, or you think I'm going
I didn't make that stats. Then I don't get it.
One second.
Not even
It's a really busy time right now too. My main. It's not so bad. A couple other guys.
Go over some data. Kind of resolve, I guess,
Play-by-play data. Coaches and
I work with some like mixed method models to identify Oh yeah, it's really cool. Yeah, it's pretty I didn't know this is back end. So I reported to this boss in the video department and to the head of the recruiting. Yeah. So, and they creating reports. Yeah. I mean, it's hard to be in sports other than power. Oh yeah. How about
Right, but it can go either way.
Yeah.
Right, exactly.
they looking kind of so.
Yes.
Their last name. I want a person last name. Yeah, I think that's
All yeah, on the
What?
But then like Thursday through like Saturday. Like, okay, I have a little time. Yeah, I can be so that's kind of I'm doing it
It's mostly like
It's just think about where if they want to, then it's
All right, are we back? Are we ready? Yes.
We are going to do something on a sample parameter, the standard deviation. We did just in mean, but we are going to do something for a standard deviation.
I don't know that SAS does a standard deviation compared to a value. It'll do two standard deviations compared to each other, but I don't know that it does a standard deviation compared to each value.
You know why I'm asking that question?
Nope.
Related to assignment.
Why are you asking the question?
Because there is one specific question in assignment saying, is it justified about the standard deviation? So you answer that visually, or is there a test to do?
No. So for your homework assignment, you just say yes. They look the same. Yeah.
Thank you.
You're welcome. Yeah. So yes. So I'm going to do one more thing in SAS, just to show you, just to make a point. Then we'll talk about assignment 4, and the things that my other class was having issues with. All right. So real quickly, if we, so the one thing I do want to change, the one thing we do want to talk about really quickly, I'm going to make some changes. If, just to illustrate my point, let's say that we knew that our online sales are better than our in-store sales. So instead of making the assumption that our means are different from one another, so this is the same approach that we've taken, now I'm going to make the assumption that my sample mean is going to be bigger than, so my online sales are greater than my in-store sales. So what would my alternative, or what would my null hypothesis be? Everybody's happy with less than or equal. Everybody's good with that. Okay. What changes? Okay. So all I did was change the symbols. My alpha level stays the same. My test statistic stays the same. My p-value now gets divided by 2. Okay. So I'm just looking at a one-tailed test now. So my p-value is divided by 2. So now my p-value becomes p-value is 0.0409. So now, which one's bigger, my p-value or my alpha level? Now my alpha level's bigger. So what's my conclusion? So now I'm going to reject my null hypothesis. This picture is no longer accurate. Okay, so now I'm going to reject my null hypothesis. And is there now enough evidence to support my claim? So now there is. enough evidence to support the claim that the average amount spent online is
higher.
greater than the average amount spent in store. We'll leave this part because we didn't do a one-sided confidence interval. Oh.
Could you draw the picture that would support that?
Can I draw the picture of the split?
Yeah.
Sure. So now, let's see. My alpha level, all of it over here is 0.05. So I'm only interested in this one side. And now my p-value, since I cut it in half, given the calculations this SAS did for me. Alright, so now my p-value is this piece. 0.49. And now, the probability that I'm going to get something that's at least as extreme as this is 4%. Well, I'm okay with 5%. So everybody's happy. Now there's enough evidence to support my claim. So depending on your hypothesis, it doesn't always, but it can make a difference in your conclusion. Yes.
Would there be a question in the test which says that if I have this as the alpha and this is the p-value, what could be the hypothesis?
So, yes. So could I give you, like for the test, could I give you this output just like this and ask you what's the null and alternative hypothesis? You tell me. And ask you what's the test statistic, and ask you what's the p-value, and then ask you what's your statistical conclusion, and then ask you what does it mean? Absolutely. This would be a great 5-point test question. Yes.
Although just by looking at the table, we don't know we wouldn't be able to tell the null and alternative.
Right, so I give you a scenario in the table. Yeah. So given a scenario and the result, now answer the rest of the questions. Yeah. Magic, guys, right there. You just do it. No, I give you a scenario.
So if we wanted to know if it was greater than 60, which hypothesis test would we use? The first one or the greater than?
So if you want to know greater than 60, then you would use this setup.
Correct.
Yeah.
Because I guess if you equal, you could get a false positive. It's like way lower. Right? So if like the mean was lower because it's on the other end of the tail.
Yes. Then no, it would still work out for you. So even if the sample mean was like 50, because you're looking at it from the upper perspective, you should still be okay. But you're right, if it was drastically different, like if it was 40, I'll have to think about that. I mean, I see where you're going. I just need to convince myself that yes, that's a possibility. It's going to have to be a really extreme difference for that to happen. But I think theoretically it could. Yes.
Every time I look at the picture, I get really confused. I don't understand. I can't. The p-value at the alpha level, how that means whether you accept or reject it based on the picture.
So it's not based on the picture. I mean, I guess it is. If the colors overlap, you reject.
Right.
And if they don't overlap, then you don't reject.
But why?
But why?
That was my question.
Okay.
Good.
Okay, we're going to do it. All right. Well, no, so I'm looking at all the things I want to do. You know what? Actually, I'm not. Okay. That is an excellent question. And I want to tell you the answer to the question. And I will tell you the answer to the question. There's also more things that we're going to do, and we're going to be spending time on hypothesis testing for the next 5 weeks. So let's hold that question because it shouldn't impact your answers.
Okay. Just know that.
Just know it won't impact your test. Okay. So just know that I will get into, because what I need to do is we need to get into a deep conversation about the critical value approach and the p-value approach, and then I'm going to tie it all together, and all the shading is going to make sense.
Okay.
But I don't want to do that because the critical value approach isn't on your test, and I don't want to confuse you with stuff that's not on your test yet. So when we talk about independent t-test next week, after the test, I will totally draw all the pictures and make it all make sense. Is that fair enough?
Cool.
Is everybody okay with that? So for now, you're going to go on blind trust that if the p-value is less than the alpha level, you reject the null hypothesis. And then next week, I will draw all the pictures, and I think that'll help. Yes.
As far as how to think about it, just real quick, does it help to think what we're trying to do in hypothesis testing is we're trying to accept the alternative hypothesis rather than, like, we're trying to prove that what we're trying to do is work towards the alternative hypothesis, not the null hypothesis.
Sometimes.
Like, as far as the reason we want the p-value, it's a good thing that the p-value is less than the alpha level.
So
because
yes.
that's what we want. We want the alternative hypothesis to be.
That's our question.
So the reason I keep saying sometimes is so one of the assumptions that we're going to make is that this data is normally distributed. And so if we make the assumption that this data is normally distributed, then the null hypothesis is that it's normal, and the alternative is that it's not normal. Well, I want my data to be normally distributed. Therefore, I'm very happy when I fail to reject the null hypothesis, because that's actually what I want. I want it to be normal. So I like the direction that you're going and that you're thinking, but it's not, we don't always want to reject the null hypothesis, right? When we're doing a statistical study and we're trying to show that these two things are different, then yes, we want to reject the null hypothesis. But let's say that I really want to keep my brick and mortar store, right? So I see online's the way to go, but I really want to keep my brick and mortar store. Well, by my first example, there's not enough evidence to say that online sales are better than my in-store sales, so there's no reason that I need to get rid of my brick and mortar store. But with this example, I'm showing you that, yeah, there is enough evidence to conclude that your online sales are higher than your in-store sales, so maybe we need to start thinking about phasing out in-store and putting more effort towards the online. So depending on what you want,
Right.
then it could make a difference. Does that help? So I like the thought process, but you also got to think bigger scenarios too. Yes?
Going back to step 1.
Going back to step 1.
Sorry. See, we discussed last class about the blue approach and the green approach.
Yes.
The green approach would be less than equal to the blue approach being equal to.
Yes.
I thought I understood it, but I didn't.
So here's what I
Green makes
decided.
sense. Blue is not making sense to me.
And so we're just going to ditch it.
Okay.
So what I've decided to do, after much talking, I am going to stick with what your textbook says, and that's how we're going to do things, because this is your textbook, and if you're reading your textbook, I don't want to contradict your textbook. However, if you would like to read my textbook, so my textbook is educational, it's education and philosophy, or education and psychology, is where my training's from. And so if you read that textbook, then it's going to show you that the null hypothesis is always equals to. And that's just the assumption that it makes. It's like, no matter what your alternative hypothesis is, the null hypothesis is just always equal to. And then you have the insight to interpret the results correctly. This text shows it to you in a way so that it's very, very clear. If you're rejecting your null, then this is what you're doing. If you're failing to reject your null, then this is what you're doing. It's just a matter of preference. But it seemed to be causing more confusion than I meant it to. So from the rest of the semester, you'll just see me doing this. and we'll just follow this one approach. Now, if your background has you doing another thing, I'm not going to count it wrong by any stretch of the imagination. But I will be following this approach. Other comments, questions, thoughts? Okay. So let me screenshot this one for you. The next thing we're going to do is talk about your homework assignment really quickly. See, and this is what I love that you guys ask questions. Like, that is the best thing. I think that's some of the deepest learning. Then you totally throw off my schedule. All right. We'll just add this to the blank slide. So if we go to your assignments really quickly. So how are we feeling about assignments? Are we feeling better? Are we happier that we have more time? All right, so I put some stuff on the discussion board. How many of you guys actually looked at the discussion board for this class? Okay. Hey, it might have given you some hints and tips. It also might have given you some wrong hints and tips, because I tried to do it really fast and wasn't thinking and didn't read the problem correctly. So, that's why we're going to do it now. So, task 1, everybody good with task 1?
Yeah.
Okay. Task 2 on assignment number 4, guys, is the setup of quality associates. One of the big things I want you guys to think about, as we do this case study piece, don't get stuck in just the ABC that I ask you to do. Make sure to think about the big picture, because that will help you answer, right? A, B, C, D's, those are just to kind of like help you answer the big picture, right? So the big picture in this question is, we're a consulting firm, we've got this machine process, we're trying to figure out, for this manufacturing process, is it working, or do we need to have some type of corrective action? Okay, so that's the big piece that's going on. We do have a population standard deviation. If we were calculating things by hand, that would be important, but we're not, so that part really doesn't matter quite as much. We have sample sizes of 30, right? So when you pull up your data set, you should have 4 columns. Each of those columns should have 30 points in them. Okay, sample 1, sample 2, sample 3, and sample 4. What we're trying to figure out is our null hypothesis, right? So the design specifications indicate the mean of the process should be 12. We're going to test, is it 12, or is it different from 12? One-tailed test or two-tailed test? Two-tailed test. So when we get a p-value, do we have to cut it in half?
Yeah.
No. Two-tailed test, that's SAS's default, use the p-values, all is good. Everybody's like, yes, we're good. Don't have to cut it in half. Two tails, we're good. Okay. So corrective action will be taken anytime that we reject our null hypothesis. Okay. So I think the part that most of you guys are okay with. Okay. Part A. I ask you to do this every time, right? You're just looking at the samples. Tell me a little bit about the samples. What's the mean? What's the standard deviation? If you want to look at a picture, right, create a bar chart or something of that nature. Are the means the same? Is there one where the mean is definitely higher or lower? Okay. Part B, right, you're going to create a table. Right? In the table, you're going to have, like, oh, that's the bad thing about this. It goes away. So in the table, right, you're going to have the sample, you're going to have the test statistic that you get from your hypothesis test, you're going to have the p-value, you're going to have the statistical conclusion, do you reject or fail to reject, and your recommendation is pretty simple. Good to go? Corrective action needed. It's really kind of your recommendation. Right? So if you fail to reject the null hypothesis, then we're concluding that the mean is 12. That's what the process is. That's what we like. Everything's nice and happy. Good job. If we reject the null hypothesis, then what are we saying?
Adjust the process.
Yeah, the mean's not equal to 12, the mean of this sample is not equal to 12, you may need to take some corrective action. If you have more samples that need corrective action that are okay, then what should you do? Take a lot of corrective action. Let's shut the plant down for a minute. There's something really going on, right? So if all 4 samples are good, what's your overall recommendation? You're good. If 3 samples are good and 1 sample needs action,
Probably still probably all right.
you're still probably all right. What if it's 2 and 2?
Worse.
Let's take a look at this. What if it's 3 bad and 1 good? Let's shut it down, right? If all 4 are bad, stop. Right? Okay. Alright, so that's kind of what we're looking for. So part B is just creating the table. Part C says compute the standard deviation for each of the 4 samples. You guys all know descriptive statistics. Let me make this bigger so you can actually read it. You're all good with statistics. Descriptive statistics does the assumption of 0.21 for the population standard deviation appear reasonable? That is a total opinion question. Does it appear reasonable? Oh, I see why you asked me about
Yeah,
that.
it's just the justifies.
There we go. Don't justify it. Just give me your opinion. Just give me your opinion. Give me your opinion. Let's make that easier. Just tell me, does it? See, look, aren't you glad it came by? Just tell me. Just give me your opinion. Just tell me about it. And that's actually what I said. So on the discussion board, you go and you look. You'll say Part C, and I'm like, just tell me your opinion. Part D. That's the part that I messed up on the discussion board. So 2 things. If you did what I suggested on the discussion board, full points. Yay! Everybody's happy. If you did not do what I suggested on the discussion board, we're going to do the answer right now, and you're going to get the answer for free. See how this works? Okay, so Part D says compute limits for the sample mean around the population mean of 12, such that as long as a new sample mean is within those limits, the process will be considered to be operating satisfactorily. Okay. If the mean exceeds the upper limit or it's below the lower limit, then we're doing corrective action. Okay. These limits are referred to as upper and lower control limits for quality control purposes. And then justify. In this part, we are actually going to use statistics for this. Okay. So, I read this really quickly. I was busy doing something else. I tried to type something out. And basically on the discussion board, what I said was just create 4 confidence intervals. See if 12 is in those confidence intervals. And so basically, I had you repeating Part B, but doing it with confidence intervals instead of the hypothesis test. And if you did that and you've already done it and you're done, that's totally fine. That's what I said to do. Did anybody do Part D differently?
Yes, I did nothing at all.
I did nothing at all. Right. Did anybody do Part D? Have a different way to do it. That's why you come to class. All right. So really, what this is asking. Okay. So we've done the test. We figured out what's going on. Let's see. If I scroll, here's some blank space. I'm not going to screenshot this. Type it up, write it down, whatever. Okay. This is your answer to your thing. These are going to be posted later. I'm not. I mean, it'll be on the video, but I'm not going to screenshot this particular piece. Okay. So basically, what we're trying to do, right? If you're looking at the big picture for this assignment, we have got some insight. We figured out if the samples are good or bad. And we're basically trying to say, okay, well, let's set up some limits. Now that we know what's good and what's bad, let's set up some limits so that if you're above this value, I know you need corrective action. If you're below this value, I know you need corrective action. And I don't have to do a hypothesis test for every single sample. That's really what's happening. Okay, and the way we're going to do this Because we're actually just going to hand calculate a confidence interval.
Would you basically want to find like the Z-score or the Z-score whatever, and then figure out which value it like equates to that? Is that like too big?
So yeah. So I'm finding this is basically how we would hand calculate a confidence interval, right? We didn't really focus on the hand calculation of stuff. I told you didn't need to because up to this point we've always had sample data. Well, now we don't have sample data. Okay, so you could have created some sample data so that the standard deviation is 0.21 and the mean is 12, and you could have engineered it, or we can just do this by hand and say we want 12 plus or minus. The critical value you're going to need here is 1.96. You get that from the back of the book, or you just trust me. The standard deviation we're interested in is 0.21, and we're interested in taking sample sizes of 30. Right, so we're just doing this by hand. It's really what we're going to try and do. So we've got 12 plus or minus, and if you trust my math, 0.075. And so we'll have confidence intervals 11.9.925 and 12.075. And that's really what part D was asking. Was it saying create some limits with the mean being 12 so that instead of having to go through and do a hypothesis every time, you just know that if your mean of your sample is above 12.075, you need corrective action. And if your mean of that sample is below 11.925, then you need corrective action. That makes sense? Easier than you thought, but just weird wording.
Yeah.
I was trying to teach you too much in that question. All right. Next thing. Next thing. I made a mistake. I know you guys can't believe that. I made a mistake last week when I was filling out this lovely picture. Why didn't you tell me last week? Why? Why? I accepted it. Okay. Conceptually, it's all right. Technically, everything is correct. But theoretically, it doesn't make sense. Okay. So when I had my null hypothesis, I made my null hypothesis that the person was pregnant. My alternative is that you are not pregnant. And so thinking about that, using like signs, I was thinking equals pregnant and not equals pregnant. And sure. But then when you talk about a false positive, then that's when we were saying you weren't pregnant when really you were. That doesn't quite make sense for how false positives work when you think about it from like a medical perspective. So we talked about earlier, when we talked about the null hypothesis, one way to think about it is the status quo. Right? It's what's going on. So if you think about the status quo, in general, are people pregnant or not pregnant? The status quo is, for the most part, you're not pregnant. And the alternative is that you would be pregnant. So if you flip this around and make this not pregnant, and this not pregnant. And so then we're concluding you're pregnant when really you're not. That makes much more sense of a false positive, like from a theoretical perspective. So technically what we did last time was not wrong. But I know there've been like 3 or 4 people kind of come up and ask me, it's like, oh, it doesn't really make sense from what I think of when I think of a false positive. And so it's all about how you set up your null and alternative hypothesis. Okay, so just as you're studying, think through that. Come up with a different example for yourself. Okay, but I just wanted to make that correction. So if you go back and look at your notes, you need to correct that. Okay.
But also,
Same question. Is it about this, ask.
yeah, it's about that. No, it's not about this. It's about what we just said.
Okay, then ask me about this, and we'll go to him.
So on this note, kind of what we earlier said about the jury trial,
Yeah.
like the type 1 error. Like type 1 error would be convicting someone who's guilty.
Yes.
But wouldn't it also depend on
It would.
same here, like what your no?
So what would the status quo be?
You're not. They're not.
Right. So we'll assume the status quo is innocent, and then the alternative is guilty. Right? Because we assume you're innocent until you're proven guilty.
Right.
So then we have innocent and guilty here. And then what we said earlier makes sense.
Right.
Right. Putting somebody away, so we're saying they're guilty when really they're innocent.
Right.
Make sense? We good? Okay. Just wanted to make that since you guys are studying for a test. Jacob, you had a question?
Part we just did where we calculated that confidence interval.
Mm-hmm.
The part B says for a 0.01 level of significance. Do we need to change that for part D?
Oh,
Just keep the 0.05.
Jacob. Okay. Or, this is for 95%. I'm not going to do the math on this one. 10, 12 plus or minus 2.67. Is it 6.7?
2.6.
2.58. 2.58. 1. This you get out of the back of your book. But you don't need to get it out of the back of your book because I just told you what it is. So it's 1.645, 1.96, 2.58. Yep, so that's the 99%. So if it's actually 0.01, like it is in the rest of the question, and you want to make it match, then you can use 2.58. I'm going to really go with any answer because I mean, basically if you put an answer on part D, but yes, for knowing how to do it, then that's a really good point, is that you want to have the appropriate alpha level in there. All right. Other questions? Comments, thoughts? I've asked so many great questions. We have 30 minutes of class left. This is something I thought was going to have 2 hours to do. So you have a choice. We're going to make this very democratic. For the next 30 minutes, we have 3 options. Option number 1. We will spend the next 30 minutes doing Tableau. Option number 2. We will spend the next 30 minutes working on your projects in project prep number 2. Option number 3, you get 15 minutes on each. Who wants to play with Tableau? Who wants to work on the project? Okay. We will do Tableau. Oh my gosh. I feel so horrible. I didn't foresee us having that many adventures, but do you feel more prepared for your test?
Yes.
Okay. Do you feel like you understand hypothesis testing better?
Yeah.
Okay, so was it worth it?
Yeah.
Okay, yes.
We keep going around the questions, but I just thought of this. I purchased my book online, so I don't have a physical book.
Yes.
Is there a way, like, it's through the Amazon Kindle app, so I can't, like, download it locally. I have to send it over
Okay.
to the desktop. Is there a way that we can work out, like, having access to that and being okay with it?
Oh, I see what you're saying. Like for the exam.
For the, yeah.
Yeah. Yeah. If you have bring another device
Okay.
that you can read it on. That's
Okay.
fine.
I just did not having an extra laptop you would be concerned about.
I mean, I'm gonna be walking around, and
Okay.
I'm gonna trust you guys for the most part.
Okay.
I mean,
Just curious.
I really don't think you guys are gonna okay. Right? Like, so here's the part. How many of you guys are planning to cheat on me next week? I don't perceive you're not gonna have time to really cheat.
Right.
So
Yeah.
so just bring another device next time, and you'll just want to sit somewhere where
Not the way of other people.
Is that the same thing? Yeah. So if you're gonna have that issue, then you'll just want to kind of sit in a little more, because you'll take a little more space. That's fine. Yeah. I'm okay with that. Okay. So visualization. So hey, so still, if you want to play in SAT or you want to play in Tableau, it's there. It's available. I mean, you guys got to play in Tableau a little bit in your Monday class. For those of you who have the Monday class, right?
Mm-hmm.
If you don't have a Monday class, then you can still play with Tableau. But did you get to play with it a lot or just a little bit? Just a little bit. Okay. Well, hey, anytime you want to do the Tableau exploration or part, choose your own adventure piece, go for it.